Hello there, this is Mr. Wilfert, and I just wanted to talk a little bit about your first week here in geometry and go through some of the sections that we're going to be covering here, sections 1, 2, and 3 from Chapter 1. First of all, Chapter 1, Section 1 starts out pretty basic stuff here, understanding points, lines, and planes. And of course, this is from your textbook. You certainly can look at some of these things in these examples after I go through it. I'm just going to briefly go through just a couple of things here. First of all, when we talk about a point, um, remember that we represent it with a dot, and we usually use a capital letter for a point P. We have a line. If we connect two dots together and go forever in both directions, we have a straight line. And you can see here how we indicate a line. We have a plane where we have 3 points. That's what defines a plane. And you can see there that we have some different things that we talk about in terms of plane. And then we have a couple of terms here called collinear and coplanar. Points that lie on the same line are called collinear, so we can have many points. And then we have something called coplanar, which would be points that lie on the same plane. And of course, you have different examples that you can look at as you go through your textbook. All sorts of definitions here, and that's really what we're going to be looking at quite a bit in the beginning here, is just a lot of definitions so that we're all on the same page as far as terminology and things like that. We have a segment. A segment basically is where we connect 2 points. It is not a line because it doesn't go on forever in both directions. The segment stops and it has a beginning and an ending. The endpoints of a segment are the points at the end. We have a ray where we start at one point and then we continue on forever in a direction. We have opposite rays, and really that would form a line. So another example there, and then we're going to have start talking about postulates and theorems and things like that. And so you want to make sure that you maybe make some notes of these and maybe write some of this stuff down kind of in your own terms, I guess. So if you're taking any kind of notes at all, you could just jot down some of these different postulates and kind of what they say. So through any 2 points, there's exactly one line. Through any 3 non-collinear points, there is exactly one plane containing them. And again, we kind of talked about this with 2 points defining a line, 3 points defining a plane, and so on. And then the third one here, if 2 points lie in a plane, then the line containing those points lies in the plane. So if 2 points contained in this plane, then the line that goes through those 2 points must also lie in that plane as well. Then we have a couple more postulates here as far as the intersections of lines and planes. If 2 lines intersect, then they must intersect in exactly 1 point. 2 planes intersect, then they are going to intersect in 1 line. And you can kind of take a look at some examples there. A lot of these beginning examples are just really to kind of, as I mentioned, make sure that we're all on the same page, talking the same language, and it's pretty basic stuff, just kind of naming things. As always, I should mention that if you want to see a better picture of this as you look in your online textbook, you can click on this link here, English, and that will give you a PDF file. If you want to see different lessons, video lessons, different examples, you can always click here. Those are very good. And then throughout each section, there'll be different things that you can click on the right-hand side of your online textbook. Interactivity. This is a good one, understanding points, lines, and planes. And then there's an interactive practice quiz that you can take here for each section. So I would encourage you to take a look at some of that. And then, of course, you have the glossary here of some of those terms. And then we have our problems that we're going to be doing here, so make sure that you look in class for those. I'm going to go on to the next section here. In section 2 this week, we're going to be talking about measuring and constructing segments. Now, as you go online and you do different things, you know, you don't always have the right tools. There's certain tools that we talk about maybe in geometry that you can use on your computer, but of course you can always do this on a piece of paper at home. So basically, just to start out here, when we talk about one of the most basic tools is a ruler. A ruler, we can measure distance between 2 points. We can draw straight lines and things like that. So there's a ruler postulate. And the points on a line can be put into a 1-to-1 correspondence with real numbers. So you can kind of think of this ruler as being real numbers, points on a number line. The distance between any 2 points is the absolute value of the difference of the coordinates. And we talk about the length here. So basically we want to be able to find the distance between 2 points. So you're going to be given a number line, for example, and different points on that number line, and you want to be able to find the distance between there. So sometimes it's a little bit easy, like the distance here between E and F. Basically, you can almost just count the number of units over, and you get 3. Otherwise, another way to do it is to take and really subtract the numbers. That's what this is saying here. Subtract the numbers, take the absolute value, which just means your distance is always going to be positive. So you have a couple of examples here as well. Then we want to talk about congruency. Congruent segments are segments that have the same length, and so you can take a look at some examples here. If you have, they're 2 separate different segments, but they have the same length, so we talk about them being congruent. So when we do basic constructions here in geometry, construction is a way of creating a figure that is more precise. Instead of just drawing freehand a line or different things, we can be more precise. And throughout this book, throughout our class here, you're going to notice that you have different construction problems, and they're going to kind of show you and talk about some of the tools that you can use. Hopefully you have some of these tools at home. You know, a basic ruler, a compass, for example, is something that is worthwhile to have. So you can kind of read through some of these different things here as far as doing the constructions. If you have questions, make sure you let me know. Here's another postulate. This is a segment addition postulate. And basically this is taking a segment and breaking it, kind of putting a point in between, and just the sums here, A to B, B to C, if you add those together you get the whole thing, A to C. Hopefully that makes sense to you there. But you can use that postulate with problems like this. And they throw in a little algebra here, so make sure that if you have questions as you read through this, if you don't quite understand the process of solving some of this, please let me know and I can help you out, because they do use some variables and different algebraic expressions and equations. Okay, then we have the midpoint. We can talk about the midpoint, and that is what we call bisects or divides it in half, the segment in half. The midpoint is exactly in the middle. So again, terminology here that you want to make sure that you're able to use. And then we have a segment bisector. And again, this is a nice construction problem here that they do. If you read through that, you can bisect a segment here doing a construction. A segment bisector is any ray, segment, or line that intersects a segment at the midpoint. So it's going to divide it into 2 equal parts. Okay, so that is section 2. Basically, if you have questions with any of that, please let me know. And then I just want to quickly go through section 3 here. This will be the last section that we're going to talk about this week. and this is measuring and constructing angles. So when we talk about angles, and we're going to actually talk about angles in more depth here throughout this course, but an angle basically is where we're going to take two rays and put them together, put their endpoints together. This endpoint is called the vertex. And we have a couple different angles actually that are formed. We have an interior angle, which is most of the time what we're talking about and thinking about, and then we have an exterior angle, which is the outside here. We can actually talk about that angle outside. Couple different ways that you name an angle, so you have to be careful with this a little bit. A lot of times you'll see three letters used, like right here, angle SRT. Sometimes you'll see it just as the vertex point, angle R. Sometimes you use a number for it, like angle 1. Or you could have TRS in the opposite order. But in any case, you want to just be careful and make sure that you understand which angles they're talking about. Again, typically it's going to be your interior angle. Okay, another example that goes along with that. When we measure it, the measure of an angle is usually given in degrees. We'll talk about some other ways we can measure angles, but typically for now, we want to talk about degrees. Since there are 360 degrees in a circle, 1 degree is 1/360th of a circle. So it's pretty small actually. When you use a protractor, you're measuring angles. So we have a protractor postulate. It says given AB and a point O on AB, all rays that can be drawn from O can be put into a 1-to-1 correspondence with the real numbers from 0 to 180. And so basically it's just looking at a protractor, and it's basically measuring half of a circle is what a protractor will do. And you can see that here in this picture. This is kind of like the number line, where you take a number line and you draw your axis or your real numbers here. This is just like saying, let's take half of a circle and label each of these points around this half of a circle and correspond it with these degrees, these angles. Okay, let's move on here. Then we have what we call an acute angle. Angle between 0 and 90 degrees is acute. Then we have a 90-degree angle. It's a right angle. And we have an obtuse angle, which is between 90 and 180. And then we have a straight angle, which measures 180 degrees. Basically, that's going to be your straight line. So you're going to practice here with some different examples. And using a protractor here, you're going to be able to find and measure and label really some of these angles as you go through. So it's good practice. You've probably used that kind of thing before. Congruent angles, again, basically you have two different angles, but they actually measure the same. So we talk about them being congruent angles. When we want to construct angles, then what we can do again is use a ruler or a straight edge, and then we can use a protractor here to a compass to measure some of these angles out. You can read through this. This is pretty good. Finally, then we have a angle addition postulate here. Again, this is kind of like the segment addition. When we take two angles and split them up, when we add the two parts, we get the whole thing. That is the angle addition postulate. So that's something that you'll practice with. Here's another construction. Angle bisector is when we cut an angle directly in half. You can read through that as well. Kind of like the midpoint of a segment. Again, and that's pretty much section 3. Again, make sure that you take a look at this information on the right hand side. There's a lot of good different links here, and that will help explain some things as well. Of course, if you have any questions at all, please feel free to let me know. All right, thanks and good luck this first week.